Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Vitamath 60, this is about expressing one quantity in terms of the other quantity, geometric quantity maybe. So in this case, one of the legs of a right triangle has a length 6 cm. Express the length of the altitude perpendicular to the hypotenuse as a function of the length of the hypotenuse. Then for part B, the altitude perpendicular to the hypotenuse of a right triangle is 15 cm. This is a different problem. Express the length of the hypotenuse as a function of the perimeter. So for part A, let's have the figure. So this is one leg which is 6 cm length. The hypotenuse is denoted by h, and the altitude to the hypotenuse is the one that is perpendicular to that through the perpendicular uh, corner, through the points of intersection of these legs. And we'll denote that as A, and A is just A. So we have similar triangles here, three. If we call this angle theta, by the way, in terms of the hypotenuse, this other leg, the base is square root of h square minus 6 square from this right triangle. So if we call this theta, this is also theta. So we have three similar triangles here, but let's just use two, the middle size right triangle, this one, and the largest triangle, right triangle here. So we have to apply constant ratio opposite of theta over hypotenuse. So for this intermediate size triangle, the opposite side is A, and the hypotenuse is square root of h square minus 6 square. For this biggest triangle, the opposite side is 6 and the hypotenuse is h. Therefore, A as to square root of h square minus 6 square equals 6 as to h. So the altitude therefore is 6 square root of h square minus 36 divided by h. So we have expressed the altitude to the hypotenuse of this right triangle in terms of the hypotenuse. For the second part, we will denote this as b. This is square root of h square minus b square, and the hypotenuse is denoted by h. So that's the hypotenuse. This is b, is the altitude to the hypotenuse, and this is denoted by a, and it is equal to 15. And this is b, theta, theta. You have similar triangles. This is square root of, if that is b, then this is square root of h square minus b square. The perimeter therefore is equal to b plus square root of h square minus b square plus the hypotenuse. Perimeter is equal to b, the sum of the sides. So b plus square root of h square minus b square plus h, where b is the other leg. So from the results here, because we have to apply similar triangles also, we have a, which is equal to 15, and 6 is just b, 36 is b square. So 15 equals b square root of h square minus b square all over hypotenuse. So that means square root of h square minus b square is 15h over b. So 15h over b is equal to square root of h square minus b square. We then replace this by 15h over b and plus h. So we have p minus b. We factor out h in the right side. H times quantity 15 over b plus 1. Simplifying the right side, P minus B equals H, 15 plus B over B. Then P minus B times B equal over 15 plus B is the hypotenuse. Then finally, the hypotenuse in terms of perimeter is PB, perimeter times B minus B square, all over 15 plus B. So we note that we define B as the other leg. So B is the other leg, or length of the other leg. So that's it for this problem. So this is just a word problem. We have to express one uh, element of the right triangle that is mentioned in terms of the other element or elements.